Hello everyone, welcome to the discussions of the past year questions. This video we shall discuss about further statistics, October-November 2023, paper 41. Let's take a look at the questions. Question number 1. Maya is an athlete who competes in 1,500 meters races. Last summer, her practice run times had mean 4.22 minutes. Over the winter, she has done some intense training to try to improve her times. A random sample of 10 of her practice run times, X minutes this summer are summarized as follows. Maya's new practice run times are normally distributed. She believed that on average her times have improved as a result of her training. That's at 5% significant level whether Maya believed is supported by the data. So since it's normally distributed, this one, it must be t-test because this one, the n is 10, less than 30. Okay, so what you need to do is you need to do the null hypothesis. You just say that the population mean is 4.2, okay? The population mean is 4.22 minute versus the population mean she believe her average have improved. That means will be less than 4.22. This is the one tail test. Okay, it's a left tail test to be more precise. Okay, so now we need to find the critical value. The alpha that they give you is significant level is 5%. So you're looking for the 95%. So to find the critical value, you need to find the degree of freedom. Degree of freedom is 10 minus 1, so it's 9. So it's D of 0.95 and 9. Just look from the table, formula table, the formula booklet. You have a 9 here, you have a 95 here, so it's 1.33. 1.833. Since it's left tail, so you put negative. Then we need to find the mean of the x. The mean of the x is 42.05 over 10. You get 4.205. Then the unbiased estimations of the population variance. It will be 9 here, 176.83 minus the sum of the x, 42.05 square divided by 10. Press the calculator, you get the answer 0.0010833. Okay. So now we are ready to find the test statistics. So the formula for test statistics is the mean 4.205 minus the population mean 4.22 divided by the square root of the s square divided by 10. Press the calculator and you get the answer as negative 1.44. Three significant figure. Okay, so now I take the test statistics, modulus it, and take the critical value. I modulus it, compare. You can see that the test statistics after you modulus is less than the modulus of the critical value. So for these situations, we will accept H now. So conclusion, there is insufficient evidence to support Maya's claim, to support Maya's belief. Okay, so this will be the answer for the part one, question number one. Done. Now we move on to the question number two. Okay, now we take a look at question number two. The town council has published its plans to redeveloping the town center, and residents are being asked whether they approve or disapprove. A random sample of 250 responses have been selected from residents in the four main streets in the town, north, east, south, west streets. The results are shown in the table here. Test at 5% significant level whether the opinion of the residents are independent of the streets on which they live. So over here, what you need to do is, usually I will redraw again this table. Okay, so usually we redraw again this table. I will extend with one more row here. We have North Street, East, South, West, and we have a total here. Okay. So this one is approve, disapprove. Okay. Maybe I just write the initial value. A for approve, D for disapprove, North, East, South, West. This one 33, 19. I need to sum it up. I get a 52. I write it beside, because next beside it I need to write down the expected frequency. So this one is just the observed frequency. Total is 93. 42, 38. Total is 70. Then 26 and 9. So the total is 35. The row here, sum the row up, you get 155. Sum the row, second row, you get 950. So the total, the grand total will be 250. Okay, so now I want to calculate the expected frequency for all of them here. So to calculate the expected frequency, I just take, for the first one, I just take this. Oops, sorry. For the first value, I just take this, multiply this, divide by this. Okay, so just take 52 multiply 155 divided by 250. Then you get the answer as 32.24. Okay, then now if you move to the one next below it will be 52 multiplied by 95 divided by 250. So you get 19.76. Okay, then you can double check. You can double check your answer. The two of them here, total must equal to 52. Okay, so double check, correct. So same thing, similarly, the rest you just take this, multiply this, divided by 250. So to save time, I just straight away write down all the value that I have calculated earlier. 57.66, 35.34. 43.4, 26.6, 21.7, 13.3. Okay, so this will be the table. So now we are ready to do the hypothesis. First of all, we need to write down the null hypothesis and alternative hypothesis. The null hypothesis is that we can copy the whole statement here. Opinions of the residents independent. Now please. Are independent of the street. On which they live. Versus the opinions of the resident are not independent. The streets on which they live. Okay, this is a null hypothesis and alternative hypothesis. Now we can try to find the critical value, but before that we need to find the degree of freedom. So the degree of freedom is number of rows. We have 2 rows minus 1. Multiply by the number of columns. You have 4 columns minus 1. Multiply together, you get a 3. So now your critical value is pi square of your significant level is 5%. So this one will be 95. Then this one, degree of freedom is 3. So just use your table. Let's go for the chi-square. For chi-square, you are having 95. Degree of freedom is 3. So you get 7.815. Okay, you will get 7.815. Okay, now we can find the test statistics. So this will be take us quite some time over here. Chi-square, the formula for chi-square is the OI minus the EI square over the EI. So the first one is you taking, suppose you take 33 minus the 32.24 square divided by 24. Divided by the 33.24. Okay. Then after that, you plus with the 54 minus the 57.66 square divided by 57.66 and so on. Okay. So over here, you plus until the last one. The last one will be 9 minus a 13.3 square divided by 13.3. So over here, usually I will not going to show these steps, okay? Because you're not supposed to show dot, dot, dot in between. You're not supposed to ignore the terms in between. But this one just to show how to calculate. Now, the most important is in exam, you need to show me the final value. I mean, not the final value, the value after you press the calculator, each of the value that you press by using the calculator. Okay, so this one, okay, over here, because of the space concern, the space constraint, I will erase away all this to give space for the result. Okay, so over here in exam, I will not show this. I will show this instead in exam. So I will just write down 0.01792 plus the 0.23232 plus the 0.04516 plus the 0.85207. I'm using 5 decimal places. So over here, 0.02923. Then 0.37905 plus the 0.07368. And lastly, 1.39023. So I'm using 5 decimal places. I'm not using 5 significant figure. So the total will be 3.02. Straight away rounded it up to 3 decimal place. 3 significant figure to be more precise. Okay. So now the chi-square and the critical value. The test statistics and the critical value, if you compare, no need to put modulus. You can see that the test statistics is less than the critical value. So over here, you still accept H now. Now you can give conclusion. So there is insufficient evidence. Oh, except H now, sorry. Except H now means there is sufficient. There is sufficient evidence to support that the opinion of residents are independent. Independent of the street. On which they live. Okay, done for this question number 2. Okay, so now we move on to question number 3. Okay, now question number 3. Scientists are studying the effects of exercise on LDL blood cholesterol levels. Over a 3-month period, a large group of people exercise for 20 minutes each day. For a random chosen sample of 10 of these people, the LDL blood cholesterol levels were measured at the beginning and the end of the 3-month period. The result measured in the suitable units are as follows. So these are the results. Same person, but you have 2 sets of data. One is beginning, one is the end. So it's actually same object, same subject. So what you can see is that this is supposed to be the match pair t-test. It's a match pair t-test. Okay. Test at 2.5% significant level whether there is evidence that the population mean LDL blood cholesterol level has reduced by more than 2 units after 3 months period. Okay, so this one is I'm going to use match pair t-test. I'm not going to use match pair Wilcoxon because the question didn't mention Wilcoxon. So they didn't mention Wilcoxon. So we're not going to use Wilcoxon. We only use Wilcoxon when they mention Wilcoxon. So this one we will use match pair t-test. So over here, I will need to build a small table here to find the difference. Okay, so the difference D is the beginning minus the end. Because we are supposed that the beginning, the level is supposed to be higher. Okay, so B, I think we just take B minus E lah. B is equal to the B minus E. I forgot to write down the, supposed to have 2 rows here. This is the D equal to the B minus the E. That is a person A person B, C, D, E, F, G, H, I, and J. Okay, so I take the first value, the first row value minus the second row value one by one. I have 8, 8, 15, -2, -3, 20, -3, 0, 5, and then 4. Okay. So then the questions now we need to find the sum and the sum of the D square. The sum of the D is 52. To save time, I calculated earlier. Sum of the D square is 816. And I want to find the mean. It's 52 divided by 10, you get 5.2. The unbiased population variance of the D, 1/9 of the 816 minus the 52 square over 10. Press the calculator, you get 60.622. Okay, so these are the value I need. These are the data I need for doing the hypothesis test. The null hypothesis and the population, the null hypothesis and the alternative hypothesis. So this one, it will be the population mean of the difference. I would say mu D. Mu D is 2. Mu D is 2. Okay, because the question mentioned more than 2. You see the question they mentioned more than 2. So this one is 2 versus the population median. Population mean, not median, mean is more than 2. Okay, so this one is the right here. Okay, now we can find the critical value. So the critical value, your degree of freedom is 9 and your significant level is 2.5%. So it's 97.5% and the degree of freedom is 9 from the table. 2.262. Okay, so it will be 2.262. Then test statistics. Test statistics is D is equals to the mean of D 5.2 minus the population mean 2 divided by the square root of 60.622 divided by 10. Press the calculator, you get 1.30 if you want to make it become 3 significant figure. Okay, so now you compare the modulus of the test statistics and the modulus of the critical value. So you can see that the test statistics is less than the critical value. So you have to accept H naught. So conclusion. There is insufficient evidence to support that the population mean of the difference mu D is greater than 2. Okay, I just write like this will do. Okay, so this will be the answer for the part A. Now we want to move on to the part B. State any assumption that you made in part A. So these questions you can see that I'm using a t-test, but the question never mentioned normally distributed. The question never mentioned this is normally distributed. So over here, the assumption that I have to make will be the population mean. Population differences are normally distributed. So that will be the answer for the part B. Okay, so now we move on. Question number 4. Okay, now we take a look at question number 4. Continuous random variable. As shown in the diagram, the continuous random variable x has a PDF f given by following here. M, K, and C are constant. So the question given you that the probability for x less than equal to 2 is 1/3. That means the area here is 1/3. Okay, so they want you to show that the M is equal to 1/6. After that, we want to find the value of K and C. So what we can do is that we start from here. So this one, you can use the area of the triangle formula to get the answer, or you can integrate this. Over here, I will integrate. So integrate, you get mx squared over 2 from 0 to 2. I continue over here. I get this one as a 2m minus a 0 equals to 1/3, and your m is equal to 1/6. So this is how you show the m is equal to 1/6. Now we are ready to find the k and c. So over here, we know that the f2 is equals to the m2. Okay, because if you put 2 here, and if you put 2 here, these two value, they must be matched, because this is the point that they share in common. So I will have k2 square plus c equal to 2m. But m, I have found that m is a 1/6. M is a 1/6. So you have k over 4 plus c is equal to 1/3. Multiply by 4, I get k plus 4c is equal to the 4/3. That will be my first equation. And over here, another information that we can use is the area over here. Since this is a 1/3, then the remaining area will be 2/3, because the total must be a 1. The total must be a 1. So now we integrate, we find the probability for 2 to 6 is equal to 2/3. That means if we integrate 2 to 6 of the k over x squared plus c dx, I will get 2/3. So this one, you will get negative kx plus cx from 2 to 6 equal to 2/3. Negative k over 6 plus 6c minus the negative k over 2 plus 2c is equal to 2/3. Simplify it. K join with the k, c join with the c, you will get 1/3k plus the 4c is equal to 2/3. I multiply by 3. K plus 12c is equals to 2. That will be my second equation. Now I'm taking the second equation minus the first equations. I'm having xc is equal to 2 minus 4/3. Then my c, 6 minus 4, 2/3, 2/24. 2/24 is 1/12. That is my c. And from the equation 1, k is equal to the 4/3 minus the 4c. So you will get this as a 1. K is a 1. So done. That will be the answer for the k and c for the part A. Okay. So now with the value of k and c that we have, and also the m, we can find the part B. they want to find the interquartile range of the x. So to find the interquartile range of the x means we need to find the lower quartile. So from the diagram, the lower quartile must fall into here. Okay, the lower quartile must be fall into here. This one is the upper quartile must fall into here because this area will be 0.25, 1/4. Because the total area just now given is 1/3. 1/3 is greater than 1/4, right? So the lower quartile must be in the first function, in the first piece of the function. Then your upper quartile will be this part over here is also 0.25. Okay, so we're going to make use of this result. So we just need to integrate. To find the lower quartile, integrate from 0 to the lower quartile L of the mx. It will give you 1/4. So this one will give you x squared over 12 from 0 to L. You will get L squared over 12 equal to 1/4. So from here, you will get L is equals to the Z3 because your L is positive. Okay, so that is the lower quartile. That is lower quartile. Then we want to go for the upper quartile. For the upper quartile is your upper quartile to the 6 of the kx over x squared plus the cx, plus the c, sorry. C is a 1/12. This one, it will give you 1/4 as well. Okay, so I'm taking this part. I'm taking this portion. So integrate negative 1/x plus half 1/12x from u to 6 equal to 1/4. Negative 1/6 plus the 1/2 minus the negative 1/u plus u/12 is equals to 1/4. So we just expand, you get 1/u minus a u/12 is equals to, simplify it using your calculator, you get a negative 1/12. I multiply everyone by u, I get 1 minus the, I think multiply by 12u will be better. I don't want to see fractions. Avoid seeing fraction. So I get 12 minus the u square equals to the negative u. So u square minus u minus 12 equal to 0. Factorize it, u minus 4 and u plus 3. Your u will be a 4 and u will be a negative 3. Okay. But over here, u negative 3, I need to ignore. Okay. So therefore, your u must be only 4. Then your interquartile range is the u minus the L. It will be a 4 minus the Z3. That will be your answer for the question number 3 and number 4, part B. Okay, so done. Moving on. Question number 5. Okay, now we take a look at question number 5. The random variable x has the geometric distributions, and then show that the PGF is given as this, where the Q is equal to the 1 minus B. So what you need to do is that for geometric distributions, first of all, we need to know the probability is given as the Q power of R minus 1 multiplied by B, where the R is equal to the 1, 2, 3, to infinity. Okay, so the PGF is supposed to be the sum to infinity from R equal to 1, B to the power R multiplied by the BX equal to R. So this one, it will be, we can write it like this, easier. That means it's a D power 1 multiplied by B plus the D QB plus a D squared plus the D cube q square b plus the d power 4 and q power 3 and then b and so on, go to infinity. So right here you can see that they all have common factor pt, and if you factorize it out you get this. If you factorize it out, so on and so on. So right here you can see that pt just a common factor, and inside here this one are all GP, geometric progression. So what you can do is that to apply the sum to infinity of a GP, it will be a over the 1 minus r. The r is a qt. Then you will get pt divided by 1 minus qt, shown. Okay, so that will be the answer for the part A. Now we move on to the part B. We want to use a PGF that we found to find the variance. So we differentiate for the first time. This one is a quotient rule. Keep the bottom, differentiate the top, minus keep the top, differentiate the bottom, divided by the bottom square. So you can see that your numerator, if you expand them, the QPT can be cancelled. At the end, you have only P divided by 1 minus QT square. Differentiate it for the second time. You get negative 2P negative Q divided by the 1 minus QT cube. So you get 2PQ divided by this 1 minus QT cube. Okay, so this is what you have. Then to find variance, the variance is actually the form. I think we better find out the value of the gx prime 1 and the gx double prime 1. So this one, if you substitute it, you will get 1 minus the 1 minus q square. Okay. But 1 minus q, we know that 1 minus q is a b. So it's a 1 over b. So this one, it will be a 2pq over the 1 minus q square. So it will be 2pq over the p square, a p cube. So it will be a 2q of the p square. Okay. Then your variance x will be the gx double prime. This is the formula for the variance. So just substitute in, you get the 2q over p square plus the 1 over p minus the 1 over p square. Simplify it, you will get 2q plus p minus 1. So p minus 1, okay. P minus 1, they are looking for the q, right? So p minus 1 is actually 1 minus p minus, you bring the factorized negative out. Then you know that this is a q. 2q minus a q divided by p square. So at the end you get q divided by p square. So this is the answer shown. That will be the answer for the part B. So now we move on. CAIE throws an ordinary sphere 6-sided dice repeatedly. Random variable x is the number of throws that CAIE takes in order to obtain the 6. Okay, then the probability, the random variable z denotes the sum for the two independent value of x. Okay, the sum of the two independent value of x. So first of all, we need to define x, that x is a geometric distribution because it's throw until you get the 6. So the chances to get a 6 is a 1 over 6. Okay, so the gxt, the b is a 1 over 6 from the result that we have earlier. So this one is a 5 over 60. Then you can get this one as a d 6 minus a 5t. Then the G's and the Z is actually the sum for the two independent x. So the GZT is equal to the G of x1 plus x2t. That means it's the gx1t multiplied by gx2t, which means that it is a d of 6 minus a 5t multiplied by the same thing. But since it's multiplied the same thing, we don't need to write like this. We just write a square will do. Just write a square will do. Done. That will be the answer for the question number 5C. Okay. So moving on, we will go for the question number okay. Now we take a look at question number 5. Question number 6. This one is quite long, so to save time, I have built the table earlier. So a school is conducting an experiment to see whether the distance that children can throw a ball increases in hot weather. On a cold day, all the children at school were asked to throw a ball as far as possible. The distances thrown were measured and recorded. The median distance thrown by a random sample of 25 children was 22.0. So this is the median. Okay, so what the question mentioned is median. The children were asked to throw the ball again on a hot day. The distances thrown by the same 25 children were measured and recorded, and these distances in meter are shown below. Okay, so these are the table below here. So we have 5 set of data. So it's quite long. So to save time, I already built the table earlier. And this M over here is represented the M of the median 22.01. Okay. So all the value here, this one is they ask you to use a Wilcoxon sign rank test. So I need to take all the value minus with the median. So that means I will get a positive sign and negative sign. So that's why it's called Wilcoxon sign rank test. So if you minus it, so to save time, I have calculated earlier. So just copy down only. So this one 0.3, 6.2, negative 2.2, 1.5, 4.5, negative 4.6, 0.6, 0.7, 0.9, negative 1.8, 0.2, 5.2, 1.3, negative 3.4, 3.7, 5.0, 1.0, negative 0.5, negative 2.6, negative 1.4, 1.9, 1.7, and 2.3. So these are the differences. Then we need to rank them. So the P is representing positive. So P is for positive. Q will be negative. So this one will be 1, 2, 3. Okay, I think I just write down the rank that I have calculated earlier. So to save time, this one is the 25. This one is a 7. Then this one is a 16. 5, 6, 8. We have a 14 here. Then, wait, I make a mistake. 16. Oh, sorry, I make a mistake. This is wrong. So I calculated earlier, 16, after that, 12, 21. Then 22, and then 5, 6, 8, and then 14, 224, 10. And 19, 20, 23, 9, and 4, 18, 11, 5, 13, 17. Okay, so to save time, I calculated earlier, but in exam, you have to be very careful for getting the answer. So I need to find the sum for the P and the sum for the Q. So the sum for the P, this one is 1, 1, this one is 214. This one is a 1, 1, 1. Okay. So now we are ready to do the hypothesis test. So the null hypothesis is that the population median is equal to 22.0 versus the population median. Need to refer to the questions. Either not equal to 22, greater than 22, or less than 22. So the teacher claims that the teacher claims that the distance throw will be further when the day is hot. So it will be more than 22.0. Okay, so this one is one tail. The left tail and right tail is not decided by the inequality over here. We have to check the mean. Okay, we have to check the test statistics. Okay, we have to check the test statistics first. So over here, we just say one tail. So now we already built the null hypothesis and the alternative hypothesis. Because the data is big, all the M is more than 20 already. So we need to convert it to normal distribution. So our first of all, we need to find the test statistics. The test statistics T is equals to the minimum between the 214 and 111. So obviously 111 is shorter, is lesser. So we just take T as a 111. That is my test statistics. Then my mean. I need to find critical value also. Maybe we should find the critical value first. Critical value is your alpha is 5% significant level. So this, we need to convert to the Z distribution first. So I think better we find the mean first. Formula for the mean, you can actually find in the table, formula booklet. You look for this. So you can see that this is the mean and this is the variance. So we're going to use these two formula to find the mean. So the mean, it will be equals to the formula, just apply the formula. It will be n plus 1 over 4. So it will be 25 multiply 26 over the 4. Then you get 162.5. Then the variance. Variance is, again, just a formula. Just refer to the table again. So it will be n plus 1 to n plus 1 over the 24. Then you will get this 25, 26, and 51 divided by 24. And you get this one as the 1381.25. Okay, so now your T distributions, you already make it become a normal distributions with the mean of 162.5 and the variance of 1381.25. Now we are ready to find the critical value. Your critical value will be Z distribution because I converted it to normal distribution, so we will going to use it as a Z, one tail, 95%. Okay, so this one from the formula booklet, it will be 1.65. Okay, 1.645 from the formula booklet. So now I want to use the p-value test. Yeah. Never mind. We can use the critical value test. So over here we will our test statistics. It will be the 111. Just now it's 111, right? But this one, because this 111 is from the discrete one, the Wilcoxon one. So now we want to use the Z distribution. We want to use a normal distribution. We need to do continuity correction. So the continuity correction will be 111.5 minus the mean, 162.5, divided by the square root of the variance. Then you get negative 1.37. Okay. So how do we get 111.5? How do we get 111.5? Okay. So over here, the mean is a 162.5. Then 111 is over here. 111 is over here. So by right, you're looking for the probability. You're supposed to looking for the probability for the t less than equal to 111. So if you going for the continuity correction, it will be 111.5. If you do the continuity correction CC, then it will be 111.5. So that's why we use 111.5, not 111. So remember, you have to use the critical value. So this test statistics is originally, this is the test statistics for the Wilcoxon, but because the N is large already, so this is the test statistics. We need to use it for compare with the critical value. Okay. So now this one, I compare this test statistics, negative 1.37. If you modulus it and you compare to the critical value that you have, you modulus it, you can see that this one is bigger. So over here, you accept H now. So conclusion. Okay, wait, let me erase this. This one no need to show in exam. No need to show this in exam. No need to show this in exam. So conclusion is there is insufficient evidence to support the teacher's claim. Okay, done. That will be the answer for the questions number 6. And moving on. Oh no, this will be the last question already. So I stop the video here.